Hey you, ready to unlock the secret language of AI?
Hope so.
Welcome to this deep dive, where today we're tackling prompt engineering. We're not just talking about, asking simple questions to things like Gemini.
Right.
We're going to explore how to craft really smart prompts, prompts that get you truly useful and insightful outputs.
That's right. And the cool thing is, our exploration today is based on a pretty detailed white paper.
Okay.
It really shows that getting good at prompt engineering isn't some, super technical skill reserved only for data scientists or developers.
So it's accessible.
Very much so. It's something anyone can learn and actually use effectively.
Absolutely. So the mission for this deep dive really is to equip you, the listener, with practical techniques
Uh-huh.
and a real understanding of what goes into a good prompt. By the end, you should feel much more confident in getting, well, powerful results from these large language models.
Without feeling overwhelmed.
Exactly, without feeling like you need a PhD in computer science. Okay, let's unpack this.
Sounds good. So, to really get the hang of prompting, it helps understand a bit about how these LMs work, under the hood.
Right, the basics.
Think of them as incredibly sophisticated prediction machines. When you give them some text, they're essentially trying to figure out the most likely next word. Or token, technically.
Token, right, like a piece of a word.
Yeah, sometimes a whole word, sometimes part of one. Based on all the text they've been trained on, they predict the next token in a sequence.
Okay, so a good prompt is like giving the LLM the right set of clues, so it can predict the kind of answer we're hoping for.
Spot on. It's less about demanding an answer and more about guiding it, steering it in the right direction.
Makes sense.
And it's important to realize that crafting effective prompts is often a process. It's iterative.
Trial and error.
Definitely trial and error. Your first attempt might not be perfect, and that's totally fine. Expected, even.
Because sometimes a bad prompt just gives you junk.
Sometimes, yeah. A poorly worded prompt can lead to responses that are way off or too vague or just not what you were looking for at all.
Which makes sense, like learning any new skill, right? You got to experiment a bit, see what works. And it's not just about the words in the prompt itself, is it? I mean, there are other levers we can pull.
Definitely. Other things that influence the output. The choice of the LLM itself matters, for one.
Like using Gemini versus something else.
Exactly. Or a more specialized model. They have different strengths, different training data.
Okay.
And beyond that, the configuration settings you choose for the model. Things like output length and sampling controls, they play a big role too.
Okay, let's talk about those configuration settings then. The white paper mentions output length. What's the key thing to know about that one?
So the output length parameter, it simply sets a limit. A maximum number of tokens the LLM will generate in its response.
Tokens again, right? Those chunks of words.
Yep. And naturally, generating more tokens takes more compute power.
So it affects speed and cost.
It can, yeah. Trade-offs in computation, speed, and potentially cost, depending on the service.
So if I just want a shorter answer, can I just crank down the output length?
Well, not really as a way to make the answer more concise in meaning. Reducing the output length is more like telling the model, stop talking after X words, even if it's mid-sentence.
So it just cuts it off like a hard stop.
Pretty much. It's more of a cutoff switch. But being mindful of output length is important for some more advanced techniques.
Like React, you mentioned?
Yeah, like React, where you want to keep the model focused and stop it from just rambling on forever.
Got it. So it's more about setting a maximum boundary than guaranteeing brevity. Okay. Now, let's dive into sampling controls. This sounds a bit more involved.
It is a little. So when an LLM generates text, it doesn't just pick the single best next word.
It calculates probabilities.
Exactly, for all the possible next words in its vocabulary. Sampling controls are the settings that determine how it uses those probabilities to pick the actual next word.
And the main ones are temperature, top K, and top P.
Those are the big three, yeah.
Let's start with temperature. That sounds intuitive. Like it controls how predictable or surprising the AI is.
You're right on track. Temperature controls the randomness in the word selection. A lower temperature, say closer to 0.
More predictable.
Right. Makes the model more deterministic. It'll consistently choose the word with the highest probability.
Good for facts.
Yeah, useful when you need factual, predictable answers. Think of it like always choosing the most obvious next word.
And a higher temperature. More. Wild.
Maybe. It injects more randomness. The model becomes more likely to pick words with lower probabilities.
Leading to more creative stuff.
Exactly. More diverse, creative, sometimes unexpected results. It's like the model is taking more chances.
Like for writing a story or something.
Perfect example. A higher temperature might lead to more imaginative phrasing. The white paper actually mentions the softmax function.
Ah, the machine learning term.
Yeah, it helps assign these probabilities. Low temp makes the top probability really high. High temp evens them out more.
Okay, that makes sense. What about top K and top P? How do they fit in?
Both top K and top P are ways to narrow down the pool of words the model even considers for the next step.
Okay, filtering before picking.
Pretty much. Top K sampling looks at the, well, top K most probable words. K is just a number you set.
So if K is 10, it only looks at the 10 most likely words.
Exactly. And it selects only from that list. Higher K gives more options, potentially more creativity.
And a low K, like K1.
Top K of 1 is basically just picking the single most likely word every time. Sometimes called greedy decoding, always grabs the top option.
Gotcha. And top P, how's it different?
Top P, or nucleus sampling, works with cumulative probability.
Cumulative, so adding probabilities up.
Right. It selects the smallest set of top words whose total probability adds up to more than a certain value, P.
P is like a threshold between 0 and 1.
Yep. Like top K, lower P makes it more focused, higher P allows more variety. A P near 0 often just considers the single most probable word, similar to K1.
So how do these all work together? Temperature, top K, top P sounds like a lot to juggle.
They do interact. If all three are available, the model first filters down the potential words based on both top K and top P settings.
Okay, a combined filter?
Then the temperature setting is applied to randomly select from that smaller filtered set.
And if only one filter is available?
It just uses that one filter. Then temperature, if it's available. If temperature isn't an option, it just picks randomly from whatever words made it through the top K and or top P filter.
Okay, so what are some good starting points if I'm just messing around?
Good question. The white paper suggests for generally coherent but still kind of creative results, try maybe temperature on 0.2, top P 195, and top K of 30.
Okay, a balanced start. And for really creative.
You might crank it up, maybe temp 0.9, top P 0.99, top K of 40, something like that.
And the opposite, factual, less creative.
Lower temp, definitely. Maybe 0.1, top P maybe 0.9, top K around 20.
And if there's like one right answer, math problems.
Temperature of 0 is often your best bet there.
Yeah.
Maximum determinism.
That's really helpful, just having some rough guidelines. Now, there's a warning in the white paper about something called the repetition loop bug. That sounds annoying.
It can be super frustrating. It's when the LLM gets stuck. Repeats the same word or phrase or sentence structure over and over, often with filler words.
Ugh, why does that happen?
Interestingly, it can happen at both low and high temperatures.
Oh.
At low temps, the model can become too focused on the single most probable path, which might accidentally lead it back to something it just said.
Okay.
At high temps, the randomness increases the chance that a randomly chosen word just happens to loop it back into a previous pattern.
So you need a balance?
Exactly. Carefully adjusting temp and top K, top P to find that sweet spot between predictable and random is usually the key to fixing it.
Okay, good to know. It really sounds like tweaking these output settings is almost as crucial as, writing the prompt itself.
It absolutely is. They work hand in hand.
Yeah. All right, so let's move on to the actual prompting techniques. The first one mentioned is general prompting or zero-shot prompting. What's the core idea there?
Zero shot is basically the simplest form. You just give the LM a description of the task.
Like write a poem?
Yeah, or classify this review, along with some initial text, the question, the start of the story, the instruction.
And zero-shot means no examples.
Precisely. No examples of the kind of output you want. You're relying entirely on the model's existing knowledge from its training.
So it has to figure out what I mean just from the instruction.
Exactly. Based purely on what it learned during training. The white paper shows an example classifying a movie review as positive, neutral, or negative.
Just give it the review and ask.
Yep. And for tasks like that, deterministic ones, low temperature is generally recommended for consistent results.
Okay, so it's like giving a direct order, assuming it knows how. What if that's not enough? What if zero-shot doesn't quite cut it?
That's where one-shot and few-shot prompting come in. They're really valuable when the zero-shot approach isn't quite guiding the model enough.
So you give it hints, examples.
Exactly. Providing examples can be incredibly effective. A one-shot prompt includes a single example. Here's an input, here's the kind of output I want.
Just one.
Just one for one shot. FewShot takes it further, providing multiple examples, usually like 3 to 5 is a good rule of thumb.
To show a more robust pattern.
Precisely. It gives the model a clearer idea of the input-output relationship you're after.
So it's like saying, look, here's one I did earlier, or here are a few, now you do the next one like this.
That's a perfect way to put it. The examples steer the model towards a specific output structure or style. The white paper uses that pizza order example.
Yeah, parsing the order into JSON.
Right. The FewShot prompt shows a couple of examples of customer orders translated into that structured JSON output. It helps the model learn the format.
Makes total sense, especially for structured stuff like JSON. What makes for a good example, though? Can I just throw anything in?
No, the quality is really important. They need to be directly relevant to the task, obviously. Yeah. Ideally, they should also be diverse enough to cover, typical scenarios. And crucially, the examples have to be correct. High quality.
Because garbage in, garbage out.
Pretty much. A small mistake in an example can confuse the model badly. And if you want it to handle weird inputs...
Edge cases?
Yeah, include some edge cases in your examples too. And like that pizza example showed, providing examples often means you need to bump up your allowed token limit for the prompt itself.
Right, because the examples take up space. Okay, so good, relevant, diverse, correct examples are key. Got it. Now let's talk about system, contextual, and role prompting. These sound like different ways to give more specific guidance.
They are. And while they can sometimes overlap a bit, each focuses on guiding the output by highlighting different aspects of the task.
Let's break them down. System prompting.
System prompting is all about setting the overarching context, the purpose for the LLM. It defines the big picture.
Like, you are a helpful assistant, or you are a translator.
Exactly, or like in the white paper, classify movie reviews. But you can also use it to specify how to output, like use uppercase, or output as JSON.
Oh, so it controls structure too.
Yep, control structure, can set the tone, and it's also useful for safety, like instructing it to avoid harmful content.
Okay. And role prompting, is that different?
It's more specific than a general system prompt. It's like giving the AI a specific persona or identity to adopt.
Putting it in character.
Precisely. You assign a role, and that gives the model a blueprint for its tone, its style, even its assumed knowledge base.
Like the travel diet examples in the paper, one normal, one funny.
Exactly. Defining that role helps improve the quality and relevance because the model adopts that perspective. You can ask for different styles too, confrontational, descriptive, formal, humorous, lots of options.
Cool. And the third one, contextual prompting.
Contextual prompting is about giving the AI the specific background info it needs for this particular request right now.
So not the overall role, but the immediate situation.
Yes. Providing specific background relevant to the current task helps it generate more accurate, tailored responses. The example was the Retro Games blog.
Right. Telling it the blog's focus helps it suggest much better article ideas.
Exactly. Context is key for relevance.
These all seem like really smart ways to layer in more guidance. Now, step-back prompting, that sounds intriguing. Taking a step back.
It's a clever technique, yeah. Designed to help the LLM tackle complex problems more effectively. The idea is simple. First, ask the LLM a more general question related to your specific task.
Quick what?
The answer to that broader step-back question can activate relevant knowledge or provide foundational context. Then you use that information in the next prompts when you ask the specific question.
So it's like priming the AI, getting it to think about the bigger picture before the details.
That's a great way to put it. By first considering underlying principles, LLMs can sometimes generate more accurate, insightful responses to the specific problem later.
Like the video game storyline example.
Right. A direct prompt gave a generic story. But first asking the step-back question, what makes FPS levels engaging? And then feeding those insights into the actual storyline prompt.
Resulted in a much better narrative.
Much more compelling, much more tailored. It helps the model avoid getting stuck on just surface details.
That's really clever, encouraging it to access deeper knowledge. Okay, next up, chain of thought or COOT prompting. I feel like I've heard this term a lot.
You probably have, and for good reason. COOT is a really powerful technique, especially for improving reasoning in LLMs. Complex tasks, math problems, that sort of thing.
So what's the core idea?
It's pretty simple, actually. You prompt the model to explicitly show its reasoning steps before it gives the final answer.
Like, show your work.
It's exactly like show your work. This helps the LLM break down the problem into smaller, more manageable parts, and often that leads to a more accurate solution.
Can you just tell it, think step by step?
You can. That's zero-shot COT. But it's often even more effective if you combine it with few-shot prompting. Show it an example or two of the kind of reasoning steps you want.
Okay, so instead of just asking for the answer, you ask it to walk through its thought process first. What are the benefits?
Several. It's relatively low effort to implement, works well with standard off-the-shelf LLMs, no special tuning needed.
And it's more transparent.
Big benefit. You can see the steps it took. If it makes a mistake, you can often see where the reasoning went wrong. Makes debugging much easier.
That sounds super useful.
And interestingly, it also seems to make prompts more robust. They tend to work better across different versions or updates of an LLM.
Are there downsides? Seems pretty great.
The main ones are pretty logical because it's generating all those intermediate steps.
The output is longer? Uses more tokens?
Yeah, exactly. Longer response, more tokens. So it might take slightly longer to get the answer and potentially cost more if you're paying per token.
Right. The white paper had that math problem example.
Yeah, a clear one. Direct prompt gets it wrong, add let's think step by step, and boom, it breaks it down correctly, gets the right answer. There's also a one-shot CoTee example showing how to guide the reasoning with an example.
And you mentioned it's good for code generation too.
Yeah, breaking down coding requirements into steps is helpful. Also, for creating synthetic data, you can guide the model through the assumptions it needs to make.
Okay, CoTee is about showing the work. Now, self-consistency, that sounds like it builds on CoTee.
It does, yeah. Self-consistency takes chain of thought a step further. Standard CoTee often relies on the model's single most likely reasoning path.
Okay.
Self-consistency says, let's generate multiple different reasoning paths for the same problem. You do this by using a higher temperature setting to get more variation.
Right, more randomness, so you get different ways of solving it.
Potentially, yes. Different lines of reasoning. Then you look at all the final answers generated across these different paths.
And pick the most common one.
Exactly. You select the answer that appears most consistently, like a majority vote on the final answer.
That sounds more robust, like it reduces the chance of a single fluke in reasoning?
It does. It can improve accuracy and reliability, especially for tasks where there might be multiple valid ways to reason towards a solution.
But I bet it's more expensive.
That's the trade-off. It definitely has a higher computational cost because you're essentially running the prompt multiple times to get those different paths.
So the steps are generate diverse paths, pull out the answers, pick the most frequent one.
Yep, that's the process. The white paper used that email classification example. Zero-shot CoTee might give slightly different answers sometimes, but self-consistency aims for the most reliably correct one by checking across multiple attempts.
Okay, like asking a committee of slightly different AIs and taking the consensus. What about tree of thoughts, or TOTI? That sounds even more complex.
It is a step up in complexity. Tree of thoughts is a generalization of chain of thought, instead of just one linear sequence of steps.
Like CoTee.
Right. TOTI allows the LLM to explore multiple potential reasoning paths simultaneously. It can branch out at different points.
Like exploring different options.
Exactly. You can picture like a tree. Each branch is a different intermediate thought or decision. This makes it really well suited for complex tasks needing exploration or planning.
So if one path hits a dead end, it can backtrack and try another branch.
That's the core idea.
Yeah.
It allows for a more flexible, deliberate, almost search-like problem-solving process.
Okay, interesting. Now let's shift gears a bit to REACT. That stands for reason and act, right? This sounds like it brings in the real world, external tools.
Exactly. REACT is a really powerful paradigm. It lets LLMs solve complex tasks by combining their natural language reasoning
The thinking part.
with the ability to interact with external tools. Things like search engines, code interpreters, databases, APIs.
So it can do stuff, not just talk.
Precisely. It allows the LLM to not only think about a problem, but also to take actions like searching the web, running code to gather more information or perform operations.
And then use that information.
Yes. Use the results of those actions to inform its next reasoning step. It's a big step towards creating more capable AI agents that can actually accomplish tasks.
So it mirrors how we solve problems. Reason, maybe Google something, update our thinking.
That's the analogy. The REACT process is often described as a loop. Reason, think, plan, act, use a tool, observe, see the tool's output, and then back to reason, update understanding, plan next step.
The white paper had that Python code example, finding info about Metallica.
Yeah, using LangChain. It showed the LLM deciding it needed to search, performing the search, getting results, then maybe doing another search based on the first results, and finally combining the info.
That seems really powerful. Does it need special prompting?
Implementing REACT effectively often involves careful prompt design. Yeah, you need to guide both the reasoning, what should I do next, and the action taking, what tools should I use and how. It often requires sending prompts and responses back and forth between the LLM and the tools. Examples and clear instructions in the prompt are key.
Wow. Okay. The AI actively going out and finding info. Cool. Now, the last technique mentioned was automatic prompt engineering, or APE. This sounds like AI prompting AI.
You got it. That's
Yeah.
exactly what it is. APE is a method where you use one language model to generate multiple different versions of prompts for a specific task you want another LLM to perform.
Okay. Then what?
Then, these automatically generated prompts are evaluated, often using metrics that compare the output they produce to a known good answer or standard.
Like BLAU or Mujay scores?
Yeah, things like that, or simpler accuracy
Hmm.
checks. And the best performing prompt, the one that gets the target LLM to produce the best result, is selected.
So it automates finding good prompts, which can be tedious.
Exactly. It can help automate that often time-consuming process and can sometimes even discover prompts that are more effective than ones a human might intuitively write.
Like having an AI prompt writing assistant. The paper mentioned a band march example.
Right. Using APE to refine prompts for a customer service chatbot ordering a t-shirt. You start with basic prompt, use an instructor model to generate variations, test those variations.
See which ones work best for understanding the order.
Yep. And then you can even iterate, refine the best ones further, and reevaluate.
Fascinating. The field is even automating itself. Okay, let's switch focus slightly. The white paper also talks specifically about code prompting. Models like Gemini aren't just for words.
Absolutely not. Advanced LLMs like Gemini are incredibly useful for code-related tasks. You can prompt them to write code.
In different languages.
Yep. Various programming languages. This can be a huge time saver for developers. Automating routine tasks, generating boilerplate.
The paper had a bash script example. Renaming files.
Exactly. A practical example. But big caveat, always review and test generated code thoroughly.
Don't just copy, paste, and run.
Definitely not. Ensure it works, it's efficient, and crucially, that it doesn't introduce security vulnerabilities. Think of it as a powerful starting point, a draft, not final code.
Makes perfect sense. Treat it like a junior dev's first pass, maybe. What else can we do with code prompting?
Lots. You can prompt them to explain code. Super helpful when you encounter unfamiliar code, maybe in a legacy system or an open source project.
Or even your own code from 6 months ago.
Absolutely. The paper shows asking the model to explain that same bash script.
Okay. Writing, explaining, what else?
Translating code
Right.
from one language to another, useful for migrations or leveraging different language strengths.
Like the bash to Python example, right?
Translating the script, maybe because Python is better suited for a web app interacting with it. The paper noted you might need to ensure the output format handles things like Python indentation correctly, like using Markdown formatting.
Good tip. And finally, debugging.
Yes, and reviewing. Very practical. You can give the model buggy code and ask it to find the error.
Like the broken Python script example.
Exactly. The prompt asks the LLM to debug it. It not only identifies and fixes the error, but often explains why it was wrong and might even suggest further improvements.
That's like having a patient coding tutor or pair programmer. Incredibly useful. Now, before we leave techniques, just a quick touch on multimodal prompting. What's the gist?
Multimodal is kind of the next frontier. It means using multiple types of input in your prompt, not just text.
Like images, audio.
Exactly. Text, images, audio, video, code. Feeding the LLM information in different formats simultaneously to guide its response.
So the AI understands pictures and words together.
That's the idea. Leveraging the model's ability to process and integrate information from these different modalities to get more sophisticated, nuanced results. It builds on everything we've discussed, but adds these other layers. Still a rapidly developing area.
Okay, so the future involves prompting with more than just words. Very cool. All right, let's wrap up with the best practices section from the white paper. What are the key takeaways for actually doing prompt engineering well?
Several really important ones. First, and maybe most crucial, remember that finding the best prompt requires experimentation.
No magic formula?
Not usually. You need to try things out. Tools designed for this, like Vertex AI Studio, are great sandboxes for playing with prompts and settings.
Okay, experiment. What else?
Provide examples. We talked about one-shot and few-shot. It's often the single most powerful way to teach the model what you want. It dramatically improves performance for many tasks.
What about the prompt text itself? Long and complex.
Generally, no. Aim for simplicity. Design with simplicity in mind. Use clear, concise language.
Avoid jargon, unnecessary fluff.
Exactly. Be direct. Make it easy for the model and for you to understand. Using strong action verbs helps clarify the task.
Be specific about the output you want.
Yes, very important. Provide necessary details. This ties back to system and contextual prompting. Give the model enough information to know what success looks like. The paper had do-don't examples for generating a blog post. Be specific about the topic, tone, audience.
Okay. What about telling the model what not to do? Constraints.
Interestingly, the advice is often to focus more on positive instructions what to do, rather than negative constraints what not to do.
Why is that?
Positive guidance often helps the model understand the desired outcome more clearly. Negative constraints can sometimes be misinterpreted or just make the prompt more complex. Focus on what you want.
But sometimes constraints are needed for safety.
Oh, absolutely.
Yeah.
But prioritize clear positive instructions first. Also, don't forget to control the output length, either with the model configuration or by asking directly in the prompt. Summarize in one sentence, write a tweet, etc.
Good point. Any tips for making prompts more reusable?
Yes. Use variables, placeholders in your prompt that you can fill in dynamically. Instead of hard-coding Paris, use a variable like city. Makes prompts way more flexible for applications.
Smart.
Also, experiment with phrasing. Try asking as a question, a statement, an instruction. Sometimes one works better than others for a specific task.
And for few shot, anything special?
Yeah, for classification tasks, mix up the order of the classes in your examples. Don't show all the positive examples then all the negative. Interleave them to avoid bias. Starting with maybe 6 examples covering the classes is often a good baseline.
Okay. What about keeping up with model changes? They update all the time.
Crucial point. Test your prompts on newer model versions. They might have new capabilities or just behave differently. Adapt your prompts. Leverage new features.
And output formats. We mentioned JSON.
Definitely experiment. For non-creative tasks, structured formats like JSON or XML are fantastic. Makes the output predictable, easy to parse, less prone to irrelevant chatter.
Easier for computers to use.
Exactly. And if you get broken JSON back sometimes, there are libraries like JSON Repair that can often fix incomplete or slightly malformed JSON output.
Handy. The paper also mentioned working with schemas for JSON.
Yeah, that takes structured output a step further. You can provide a JSON schema in your prompt.
Like a template.
Exactly. A blueprint that defines the exact fields, data types, and structure you expect in the JSON output. Really helps ensure consistency, especially for integrating with other systems. You define the structure you need.
Very useful for reliable data extraction. Any other key practices?
Collaborate. If you're working in a team, share what you learn. Different people have different ideas, try different approaches. You'll learn faster together.
Good point. What about specifically for chain of thought?
Couple of things. Put the final answer after the reasoning steps, clearly separated. If doing self-consistency, make sure it's easy to programmatically extract just the final answer from each path. And for standard QT, usually set temperature low, like 0, since you want logical steps to likely one correct answer.
Makes sense. And finally, probably the most important habit.
Document everything. Meticulously. Keep detailed records.
What kind of a record?
The exact prompt, the model version, the settings, temp, top cake, top of you, the output you got, and your own notes. Did it work? Why? Why not?
Why is that so important?
It's invaluable for learning, for reproducing results, for testing across model updates, for debugging. The white paper even suggests a Google Sheet template for tracking this. Include things like versioning, pass-fail, feedback, maybe even links to saved prompts in tools like Vertex AI Studio.
So treat it like scientific experimentation.
Pretty much. If you're using Retrieval Augmented Generation, RAG, document the retrieval system aspects too. For operational systems, save prompts in your codebase. Use automated testing. And always remember, it's iterative. Craft, test, analyze, refine, repeat, especially as models change.
Fantastic advice. It really drives home that prompt engineering is a practical skill developed through careful practice, experimentation, and crucially, documentation.
Couldn't agree more.
So just to quickly recap our deep dive today, we've looked at the fundamentals, how LLMs work as prediction engines, the importance of configuration settings like temperature and output length. We explored a whole range of techniques, from the basic zero-shot, one-shot, few-shot,
Through system, role, contextual prompting.
to the more advanced stuff like step back, chain of thought, self-consistency, tree of thoughts, and even React and automatic prompt engineering.
We also touched on code prompting, writing, explaining, translating, debugging code.
Right, and got a peek at multimodal prompting with images and other inputs, and then wrapped with those vital best practices experimenting, using examples, simplicity, clarity, structure like JSON, documentation.
Pretty comprehensive.
Definitely. So hopefully everyone listening feels better equipped now.
Exactly. And now that you have a deeper understanding of these techniques, maybe think about how you could refine your own interactions with AI.
Yeah, move beyond just simple questions.
Yeah. Right. How can you craft more thoughtful prompts to unlock deeper insights or tackle more complex goals? What task that seemed maybe too hard before could you approach now with a well-engineered prompt?
A great thought to end on. Hopefully this deep dive has sparked some ideas and inspires everyone to experiment more.
That's the goal. Get out there and engineer some prompts.